In this video, I will explain you what is powder metallurgy and their process, manufacturing advantages, disadvantages and application. What is powder metallurgy? Powder metallurgy is a metal processing technology where metallic powders are produced and used for part production. Introduction. Powder metallurgy. It is branch of mechanical engineering and it is mainly manufacturing process that it used to make very integrate shapes. Integrate means that shape who is difficult to make shape by other methods such as casting, forming and machining etc. So they are produced by using powder metallurgy and the name suggests powder. That means we have used some metal powders in order to form components. In simplest word, we can say that metal convert into powder, then powder convert into various metal products. Example of powder metal products: gear, cams, crank, bearing, roller bearing, housing, etc. We can see here the tree diagram of powder metallurgy process. The steps are elemental or alloy metal powders, additive, next blending, then die compacting, sintering, optional secondary manufacturing, optional secondary finishing, then finished PM products. Now in detail we can see the powder metallurgy process. To convert the molten metal to powder, first step we can apply, that is atomization. Elemental or pre-alloyed metal material we can use for powder manufacturing. Elemental means a pure metal, most commonly iron, aluminum or copper. And pre-alloyed means an alloy of the required composition, most commonly copper alloys, stainless steel or high-speed steel. Let's see the other methods of producing powder. Chemical reduction of particulate compounds, electrolytic decomposition, thermal decomposition, condensation of metal vapors. In brief, we can see first step of powder formation. We know that the metal is it not available in powder form. So we have to form the powder of metal. Now the various techniques for powder formation. First, it is atomization. As name suggests, we have to break the metal into most parts. Here about atomic scale by using some techniques. What happens? We melt the metal, the powder for which we want. The powder metal to form powder. We'll take the molten metal. That metal, then we have some sprayer. We can see the animation of atomization in this. The molten metal fall down at some height. We have sprays very fast blower or sprayers that pushes that sprayers are very strong object of wind. Wind is projected here. Then what happens? Very small particles, they are blown by the air and we have the cool plate there, and when the particles are traveled they condensed on plate, then particles are cooled down. We have a vibrate attached which periodically vibrate these plates and the molten metal is atomized by using the air. Second step is blending and mixing. Blending. Combining powders of the same material but possibly different particle size. And mixing is the combining powders of different materials. Third step is compaction. Let's see how to happens in the compaction. We put the powder in the dial and we completely fill powder up to the top surface. The powder is it completely filled, the dial is slightly vibrated so that the air between the powder escapes and the complete filling of the mold or cavity, or we can say completed dial is filled in the powder. Fourth step is sintering. We supply large amount of heat at high temperature to the dial. This dial is completely filled with powder. We supply it very huge amount of heat to melt the powder. The metal powder it again melts and the metal atoms form bond. So the metal powders form a solid shape and finally we get shape for required component. Powder metal products. Products of complex shape. Products which requires the combined properties of multiple materials. Products in which powder metallurgy produces superior properties, etc. Let's see the advantages of powder metallurgy process. Elimination or reduction of machining. High production rates. Complex shapes can be produced. Wide composition variation are possible. Wide property variation are possible, etc. Disadvantages of PM process. Inferior strength properties, relatively high die cost, high material cost. Applications: first, bearing and filtering; second, complex shape components; 3, automotive components and grinding wheel.